Hi, I'm Swarupa Said, course instructor for Geotechnical Engineering 1. In this presentation, we will go through interpretation of consolidation test results. Now we will find out how to get the value of coefficient of volume change, or which is also referred to as coefficient of volume compressibility, and is denoted by MV. It is volume change of soil mass per unit volume per unit increase in effective stress. That is, it is the ratio of volumetric strain, which is nothing but change in volume, that is delta V, divided by original volume, that is V, divided by increase in effective stress, that is delta sigma V dash. We already know that delta V divided by V is equal to delta E, that is change in void ratio, divided by 1 plus E naught, where E naught is initial void ratio. So we can write equation for MV as delta E divided by delta sigma V dash into 1 plus E naught. We already have the equation for coefficient of compressibility AV as delta E divided by delta sigma V dash. So we can write equation for MV as AV divided by 1 plus E naught. E naught is the void ratio at the start of pressure increment interval. H naught represents the original height, that is the thickness of sample, which will be in mm. A is area, which is in terms of square centimeter. Volume is in terms of centimeter cube. HF is the final height of the soil sample, that is the thickness in mm. WF is the final water content, which is in terms of percentage. G is the specific gravity of soil sample. EF is final void ratio. We already know the equation, that is ES is equal to W into G. If S is 100%, we can write equation for E as WF into G. And delta E is equal to delta H, that is change in height of the sample, divided by final height, that is HF, into 1 plus EF. EF is the final void ratio. So this is what is the tabular column for the test results of the test, that is on consolidation test. First one is applied pressure, which is in terms of kilonewton per square meter. Next is final reading, which will be in terms of 10 raised to minus 2 mm. Then we can find delta H in terms of mm, which is nothing but the change in thickness or height. Negative sign to be used if there is decrease in the soil sample. Then specimen height H will be initial height of the soil sample plus or minus delta H, minus delta H for decrease in height of the soil sample. Next we need to find change in void ratio, that is delta E is equal to change in height of the soil sample divided by final height into 1 plus EF. EF is the final void ratio. Next we need to find void ratio E, and AV is equal to minus delta E, that is change in void ratio, divided by change in vertical stress, that is effective stress. And later on we can find MV using equation AV divided by 1 plus E naught. And void ratio corresponding to each pressure increment can be found out using equation E is equal to EF plus or minus delta E. Thank you.